Welcome to the history of paint. Look up, way up, at the giants that define our modern cities, the towering skyscrapers, the vast bridges, the stadiums that span acres. What holds these colossal structures against the wind and gravity? What is their hidden strength? The answer is a material that revolutionized the world, steel. It's the essential backbone of modern life. But its journey from a rare commodity to an indispensable building block is a remarkable story of human ingenuity. Join me as we trace the history. For millennia, construction relied on the materials nature provided: wood, stone, and brick. Before steel, we had iron. Cast iron was structurally useful, as proven by 18th century masterpieces like the Iron Bridge in England. But iron has a major flaw. It's brittle and prone to breaking under tension, limiting the height and span of structures. To truly build up and out, humanity needed a material with both the compressive strength of iron and the necessary tensile elasticity. That material, of course, is steel, an alloy of iron and carbon. It is vastly stronger and more resilient than iron, but for most of history, making high-quality steel was slow, expensive, and difficult, restricting its use to things like tools and weapons, not entire buildings. We still see across Europe today. At the same time, in areas with the right geology, like Wales or Vermont, people began splitting stone. Everything changed in the mid-19th century. In 1856, the British inventor Sir Henry Bessemer introduced the Bessemer process. This groundbreaking allowed for the mass production of cheap, consistent, high-quality steel by blowing air through molten pig iron to rapidly burn away impurities. It was a manufacturing revolution that dropped the cost of steel by as much as 80%. Steel suddenly affordable and ready to build the future. The first structures to test this new affordable steel were bridges, like the magnificent Eads Bridge in St. Louis in 1874. But the most important leap was yet to come. The true steel revolution was the invention of the steel frame. Instead of relying on heavy, thick, load-bearing exterior walls, the steel frame created an internal skeleton. In 1901, with the invention of the asphalt shingle. Span of buildings. This was the era where paint became an essential protective layer. This internal skeleton bore the building's weight, freeing architects to use thinner curtain walls and vast expanses of glass. The world's first true skyscraper, Chicago's Home Insurance Building, erected in 1885, utilized this method. Though only 10 stories, it demonstrated the potential. 4 years later, Paris unveiled the Eiffel Tower, proving steel could achieve both unprecedented height and delicate, complex forms. The early 20th century became the age of the skyscraper. With reliable, standardized structural steel shapes, the classic I-beam chief among them, construction became faster, taller, and more predictable. Structures like the Chrysler Building and the Empire State Building in New York City became global symbols of industrial power and architectural ambition. Steel's strength and lightness allowed for the open-plan offices and vast spaces we take for granted today. Its ability to work seamlessly with today, steel remains the dominant structural material. From suspension bridges that span miles to prefabricated building systems, it provides the essential balance of strength, ductility, and cost. Modern innovation focuses on high-performance steels that are lighter and more corrosion-resistant. Crucially, steel is also the most recycled material on the planet, giving it a strong advantage as we move toward a more sustainable. The story of steel is a story of continuous progress. It allowed us to break free from the constraints of masonry and build the vertical cities of our dreams. So the next time you gaze upon a skyscraper, remember the invisible skeleton of steel that is holding the entire modern world together. Thank you for watching. Visit us at www.constructionsoftwarethailand.com.